All right, welcome to Ace Your IB Math exams in 10 weeks. This is week number 8. We're almost there, just 3 more to go, counting this one. I'm Bruno, the IB Math teacher. Hopefully you know me. If you don't, I used to work as the head of department in one of the most prestigious IB schools in Brazil, also an HL math teacher, and also an IB math examiner. For this May 2026 cohort, I've decided to launch a 10-week course, or you might call it a 10-week challenge, where we go through each week through 5 different questions from all 5 topics in IB Math: number and algebra, functions, trig, statistics, and calculus. All questions are demanding. They're mixed. They're paper 1, they're paper 2 questions, they're medium level ones, they're hard ones. So this is a way for us to mimic the real scenario. Everything can be found in the description of this video, the PDF, the links for the other weeks, for the other videos. Do share these resources with your colleagues so you guys can study together. Let's get to it. Let's get through week number 8. All right, so for this first exercise, we have a system of equations, and these 2 equations involve logs and exponentials. Now, this can be misleading in the sense that it doesn't look that complicated, but let's see if that's actually the case. So we have 2 equations, equation 1 and equation 2. I'm going to label them right here. And the idea here is to do a substitution, but before we can do that, we need to work with them a little bit. We can start with equation number 2. 3 to the ln of x is equal to 2 to the ln of y. Now, the only way for us to drop these exponents is to evaluate the lateral ln of both sides. So we're going to do ln of 3 to the ln of x equals ln of 2 to the ln of y. And using exponent rules, we can write this as ln of x times ln of 3 equals ln of y times ln of 2, which means finally that you can rewrite ln of y as ln of x times ln of 3 over ln of 2. Now let's move to equation number 1, and similarly we're going to evaluate the ln of both sides. By the way, you can rewrite this 2 ln of 2 as ln of 4, which means that this can turn into this. And by using ln on both sides, using a similar strategy to the one that we used before, we get ln of 4 times ln of 2x equals ln of 3 times ln of 3y. And again, using log properties, we have ln of 4 times ln of 2 plus ln of x equal to ln of 3 times ln of 3 plus ln of y. Now we know that ln of y can be written like this from the second equation. Therefore, we have our left-hand side equal to ln of 3 times ln of 3 plus ln of x times ln of 3 over ln of 2. Now we're kind of like halfway through there, so let's continue foiling. Ln of 4 times ln of 2 plus ln of 4 times ln of x equal to ln of 3 squared plus ln of x times ln of 3 squared, all of that over ln of 2. Now we're going to move every term that has x or ln of x to the left-hand side, and every term that does not to the right one. Ln of 4 ln of x minus ln of x ln of 3 squared over ln of 2 equal to ln of 3 squared minus ln of 4 ln of 2. Now putting ln of x as a common factor, we have ln of 4 minus ln of 3 squared over ln of 2, which is equal to ln of 3 squared minus ln of 4 times ln of 2. Now when you get to this in an IB exam, you're probably thinking about giving up or that something is off. But trust me, we're going to get some friendly numbers as results. Let's just continue. Dividing both sides by ln of 4 minus ln of 3 squared over ln of 2, we get ln of 3 squared minus ln of 4 times ln of 2 over ln of 4 minus ln of 3 squared over ln of 2. We can write the denominator as ln of 4 times ln of 2 minus ln of 3 squared, everything over ln of 2, and in the numerator we get ln of 3 squared minus ln of 4 times ln of 2, which means that we can simplify lots of terms. By the way, there's a square here. I don't know what happened to it, but it should be here. Now, these terms that we can simplify are these, but do be careful because this simplification leads to -1. Do notice that this is equal to this times -1, or the other way around, of course. So we get ln of x equal to negative ln of 2, which means that ln of x is ln of 2 to the -1, also known as 1 over 2. Therefore, x is equal to 1 over 2. So kind of a friendly result. In order to find y, we can replace x into this equation that we found before. So this is ln of 1 over 2, which is the same as negative ln of 2 times ln of 3 over ln of 2, which is equal to negative ln of 3. Now, if ln of y is equal to negative ln of 3, then ln of y is equal to ln of 3 to the -1. Therefore, y is 1 over 3. Whew. So we're done with this one. In exercise number 2, we have something that mixes functions with calculus. We have a line with equation y equals to x plus k, which is tangent to this curve right here, which is a quadratic, a parabola. Determine the value of the constant k and find the coordinates of the point of tangency. Now, in this question, you're not allowed to use your GDC. However, there's a way to plot this quadratic. Of course, without the GDC, we know how to plot quadratics. You can find the vertex, and then the y-coordinate, the x-coordinate of the vertex, and then the y-coordinate of the vertex, and draw this parabola concave up, because we know that a, for example, in this case, is positive. Therefore, it should be concave up. It is concave up. You can start with that sketch. That's going to help you a lot. So if you were, for example, writing this not in standard, but in vertex form, you could find the x-coordinate of the vertex with -b over 2a, and by a, b, and c, I mean the coefficients of this quadratic, which in this case means -3. And k is found by replacing the h value over here in x. So this is the y-coordinates of the vertex. So we have -3 squared plus 6 times -3 plus 7, which is -2. Therefore, the coordinates of the vertex are -3, -2. And if this parabola is concave up and the discriminant is greater than 0, then, well, we're going to have two x-intercepts and it's going to be concave up. The vertex is going to be below the x-axis. Now, how do we know that the discriminant is greater than 0? Well, we can just find it. B squared minus 4ac. We get 8. Therefore, we have two real roots. So this is our parabola. Now, do we know the root? Not really, and we don't particularly care about that. We know that there are two roots, so this is how the graph is going to look like. Now, we can start answering or addressing the question. This is just a overview of what's happening. And the question mentions a line with equation 2x plus k, which is tangent to the curve at some point. Now, if this is the equation of the tangent, that means that the derivative at that particular point, which is the slope of the tangent, it is equal to 2, which is positive. Therefore, there's going to be some point to the right of the vertex where the slope of the tangent is equal to 2. Now, what does it mean to have a slope of a tangent equal to 2? That means that the derivative of this curve at that point, it is equal to 2. So if we call this a, we know that f prime of a, that is going to be equal to 2. Now, we never found f prime or y prime or dy dx, which is the derivative of this quadratic. We can find it right now. If this is y, then y prime is 2x plus 6. If this was defined as a function f of x, then you would have f prime of x as 2x plus 6. So pretty much the same thing. Now, in what point is the derivative equal to 2? Well, we can take the derivative and force it to be equal to 2, which means that at that particular point, 2x plus 6 will be 2, which means 2x is equal to -4, so x is -2. So the x-coordinate of that point is -2. This is -2. And what is the y-coordinate of this point? You can just plug it into here. So -2 squared plus 6 times -2 plus 7, which is -1. Therefore, that point is -2 comma -1. And that is it. Now, do notice that the fact that we didn't have k didn't change, didn't influence, or didn't stop us from solving this exercise. Do know, however, also that there's more than one way of solving this, and this is the fastest one. Now, you might be asking, what is the second way? Well, if the line and the quadratic, they intersect at just one point, that means that when you do 2x plus k equal to x squared plus 6x plus 7, you should get just one solution, which means that by solving this quadratic, you should get just one root, which means that the discriminant of this quadratic has to be equal to 0. Now in this case, a equals 1, b equals 4, and c equals 7 minus k. So b squared minus 4ac, it should be equal to 0. Therefore, k in this case, it is equal to 3 by solving this equation. And to find the point of tangency, you plug this k equals 3 in this equation again. Or not again, but for the first time, but again using this equation. And then you find just one x value, which is the same a or x value that we found before, which is negative 2. So 2x plus 3 equals x squared plus 6x plus 7, x squared plus 4x plus 4 equals 0. That means that x plus 2 squared is equal to 0. Therefore, x is negative 2. But again, this is a much slower problem. All right, so on to a bearings question, which is a hot topic in the IB math scene. Albert sets out to explore a forest. At 8 a.m. he leaves his camp at A, so he starts right here and walks on a bearing of 130 degrees at an average speed of 4.5 kilometers per hour. He reaches site B at 9:30, which means that he hiked for 1.5 hours. If the average speed is 4.5, that means that the distance traveled, which I'm going to call AB, was 6.75 kilometers. So that's it for question A. Now he then leaves from site B on a bearing of 45 and walks 3.2 kilometers, reaching a cliff at C. Now this is a good time for me to give you a gigantic tip, a very precious one, which is whenever you have a bearings question, make sure that you always draw vertical and horizontal lines crossing these vertices. That's going to help you a lot when trying to find not only distances, but also angles. Any angle that you might want to find, it's going to be very evident if you have these lines drawn there. So these are the vertical and horizontal lines crossing A and B. And given that he leaves site B on a bearing of 45, I'm gonna complete this diagram by drawing vertex C over here in an angle which is 45 degrees. So now we can complete our diagram, and also very important is to connect the starting point and the end point. Now this is 75, and this is 3.2. Do notice that if this is 130, that means that this is 50 degrees. It's the supplementary angle. 50 plus 130 gives us the 180 that we're looking for. This is a 90-degree angle, and given that the sum of the angles in a triangle is 180, that means that this is 40 degrees, which means also that this is 50. Do notice how easy it is to find these angles if you draw these vertical and horizontal lines. And now to find AC, we're going to use the cosine rule. So AC squared equals 6.75 squared plus 3.2 squared minus 2 times 675 times 3.2 times the cosine of 95 degrees. 95, of course, being this angle right here. Now don't forget to set your calculator to degrees, and when you evaluate this, you should get for AC the root of 59.567 given that AC squared is 59.567. Don't forget to square root this. Therefore, we get approximately 7.72 kilometers. All right, so realizing that he is lost, he calls his friend Camus, who hikes directly from A to meet him at point C. We actually did this already. We just found AC, which is the distance from the camp to point C. We actually found the angle 95 in question B. So now jumping to question D, which is the last one that's missing. The bearing that Camus must take to point C, which by the way is this one, can be found by subtracting from 180 this 50 here and this angle right here, which we did not find, but we can find right now. So let's call this angle A. Using the sine rule, we have sine of A over 3.20 equals sine of 95 over AC, which is 7.71800. Don't forget to use all the digits here. So we get a sine of A of 0.413 dot dot dot. Therefore, angle A is approximately 24.4 degrees. Therefore, the bearing, which is 180 minus A minus the 50-degree angle, is approximately 106 degrees. All right, let's get to exercise number 4, one that involves normal distributions with conditional probability also as one of the last questions. So let's take a look. We have the weights of watermelons being distributed normally with a mean of 12.3 kilograms. And in this case, notice that we were not given the standard deviation. Now, the probability that a watermelon weighs less than 9 kilos is 0.15. In question A, we're asked to write down the probability that a watermelon weighs more than 15.6. And it seems like we're not going to be able to manage that or to do that given that we do not have the standard deviation. Notice the command term, write down. Write down means it shouldn't take any calculation whatsoever for you to determine the answer for this question. And how is that the case? Well, by sketching a bell curve and illustrating the mean over here in the middle, as it should be, of course, as 12.3 kilograms, or let me just write 12.3. One thing that we know is that the probability of finding a watermelon which weighs less than 9 kilograms is 0.15. So let's say that this red line, it represents 9 kilograms, and the probability, meaning the area over here of being less than 9, is 0.15. Now, due to the symmetry of a normal distribution and noticing that this gap over here is 3.3 kilograms, if we represent that gap to the right now, we should get the same area to the right, which means 0.15. Now, what is 12.3 plus this step of 3.3 to the right, or the addition of 12.3 plus 3.3? Well, that gives us the 15.6 that we were looking for in the first place, or that was mentioned in the first place by the exercise. Therefore, this probability right here is 0.15. Now, how should I write this in an exam? If it's a write down command, you can just state what the probability is. So 0.15 is already enough. Now let's move to the next question. Find the standardized value Z for 9 kilograms, meaning the z-score of a standard normal distribution that has the same probability of this 9 kilograms, meaning if you take the probability from negative infinity to this z-score in a normal standard normal distribution, that probability will be the same as the probability from negative infinity to 9 in this distribution right here. Anything that's a z-score, I'm going to represent in this color purple. So I'm going to drag all of these lines down. I'm actually going to change this color to be a little bit different. There we go. Anything that's in blue, again, represents a standard normal distribution, one with a mean of 0 and a standard deviation of 1, which means that the z-score of this mean, or any mean, it is always equal to 0. Now we need to find this z-score right here, which, as we can see, it's going to be negative. It's to the left of 0. Now we're representing this area 0.15 over here in our standard normal distribution, one that has a mean of 0 and standard deviation of 1. And we need to find this value, which is going to correspond to the z-score that gives us a probability of 0.15 to the left using your GDC. And in this case, I'm using the TI-84 to do it. The area being 0.15, the mean 0, standard deviation 1, and the tail to the left, we get as the z-score negative 1.03643 dot dot dot. Now, how do we convert the z-score back to our original variable, which is measuring the weight of these watermelons? We use z-score is x minus mean over the standard deviation. We do not have the standard deviation, and by the way, we are already answering B to I, but we will find it through this equation. We know the z-score, we know the x value associated to this z-score, which is 9. We know the mean of this distribution, 12.3, and we need to find the standard deviation. When solving this equation, we get 3.183 dot dot dot. So B to I, this is done. Now, next part. To be selected to be sold in a local market, a watermelon's weight must be within 1.2 standard deviations from the mean, which means from negative 1.2 standard deviation from the mean to the left all the way to 1.2 standard deviations from the mean to the right, which means greater than the mean. Now, what is 1.2 standard deviations? This is 1.2 times the value that we got previously, so 3.82. Therefore, 3.82 to the right and 3.82 to the left, given that the center is 12.3, means from 8.48 and 16.1. So we can write it as an interval. 8.48 is less than W, which is less than 16.1. And let me actually change this W to X because we are calling the weights of watermelons X. So there you go. This is the interval. So this is done. Now let's say you select at random a watermelon. What is the probability that it can be sold in a supermarket? Well, that pretty much means finding the area under this curve between 8.48 and 16.1, and we can find that through our GDCs. This is a normal CDF, and we get 0.770 rounded to 3 significant figures. Now we jump to the last question. Of the watermelons on the harvest, 30% of them are seeded ones, and from these, 60% are sold on the local market. Do notice that we're talking about the same watermelons on this harvest. Now, given that a watermelon selected at random is sold in the local market, find the probability that it is a seeded watermelon. Now, you're probably identifying a conditional probability over here, given that was used, these two words, given that, or this expression, and this means that a condition was given, some piece of information was given. We are talking about watermelons that got sold in the local supermarkets. How do we use conditional probability? The probability of A given B is equal to P of A and B over P of B. How do we translate this to this specific exercise? Given that the watermelon is sold in the local market, what is the probability that it's a seeded one? Well, it is the probability that it's a seeded that got sold in the market over the probability that it gets sold in the market. And notice that we have the denominator already from question C to I, which is 0.770. However, when addressing this question, you cannot round just yet. You need to use 0.769 A3 ... And what is the probability that it's seeded and sold? Well, 30% of them are seeded, and from these, 60% are sold. Therefore, the numerator is 0.3 times 0.6. When you divide 0.3 times 0.6 by 0.769 ... You get rounded to 3SF 0.234. And that's it for this question. All right, so lastly, let's jump to a demanding calculus exercise. It is very rare that students get this question correct from start to finish, so 100% of this question correct. Let's see why that's the case. We have two functions, g of x and h of x, and we have in this table certain values for these functions. So for example, g of 3 is equal to 1, and g prime, so information about its derivative as well, at 3 equal to 4, and so on and so forth. And we need to find, first of all, h of g of 3, which is a composite function, and g of h negative 1 of 3. These two do not involve the derivative. However, you do need to know how to find them in your table, or in this table. Now, what is h of g of 3, starting from ai? First of all, g of 3, it is equal to 1. So this value over here, it is 1. Then we're left with h of 1, and h of 1 is equal to 12. So this is 12. Now let's tackle a more challenging one. What is h negative 1 of 3? What you're asking there is, what is the input if the output of h is equal to 3? Meaning, we want the output of h to be equal to 3, so we're asking what is the x value that gives us that output? And that is equal to 5. Remember that we're talking about inverse functions, so it's not inputting 3 into h, but actually asking what was the input there that gave us 3 as the answer. And that is equal to 5. So we have g of 5, which is negative 3. And that's it. The easier part is done. Now on to the hardest part. Find the equation of the tangent line to the graph of f of x at x equals 5 if this function that we're creating is a product of g and h, or it's a composite function. So we have these two different scenarios. Let's start with bi. When x is equal to 5, we have f of 5 equal to g of 5 times h of 5, which is equal to negative 3 times 3, which is negative 9. Now we know that this function crosses the point 5, negative 9. And in order to find the tangent to that curve at that point, we not only need the point itself, which we have already, but also the slope of this tangent line. And to find the slope, we need to find the derivative of f. Given that f is a product between g and h, we need to use the product rule for that. So let's apply the product rule for f of x first. Now f prime of x is g prime of x times h of x plus g of x times h prime of x. This is us applying the product rule, which means that f prime of 5, which is the slope of that blue line, it is equal to g prime of 5, which is 6, times h of 5, which is 3, plus g of 5, which is negative 3, times h prime of 5, which is negative 2. So we get 24 as the slope of this tangent line. Therefore, the equation of the line is 24x plus b, and if we replace the point over here, we can find b. So b is negative 129, which means that the final equation is 24x minus 129. Now let's jump to the second part, where f of x is a composition between g and h, g of h in this case. Now, if we have a composite function, we need to apply the chain rule now to find the derivative of f and to replace the values for when x is equal to 5. So how do we apply the chain rule? F prime of x is g prime of h of x times h prime of x, which means that f prime of 5 is g prime of h of 5 times h prime of 5. H of 5, it is equal to 3, and g prime of 3, that is equal to 4. So we have 4 times h prime of 5, which is negative 2. So we have negative 8 as a result, or as the result, as the slope. Now, we never found f of 5 for this case, so let's calculate it right now. F of 5 is g of h of 5, which is g of 3, which is equal to 1. Therefore, for this particular curve, the point of tangency is 5, 1. So we have y equals negative 8x plus b, and by replacing that point, we get b equal to 41. Therefore, the final equation is negative 8x plus 41. And that's it. All right, so week number 8 is done. We just have 2 more to go, so 2 weeks to go, which means that your IB math exam is approaching. Don't freak out. We still have 2 more weeks to study together. I'll see you next week.